So we have to find out moment of inertia about the central axis for this T section. So it is a bar of T section, has flange width 50 mm and 10 mm thick, and this is web. This web is 80 mm deep and 10 mm thick. So we have to find the moment of inertia about centroidal axis. So if you want to find out moment of inertia about centroidal axis, then first of all we have to find out centroid of this total composite section. That means we have to find centroid for this T section. So before finding out centroid, so first we are going to split this T section into two components. So here I am assuming this is one first element and this is second element. So this first element, so element 1, okay, first element has depth 80 mm and 10 mm thick, and this second element or second rectangle has 10 mm width, 10 mm thickness and 50 mm width. So this T section, so it is symmetrical about y-axis. So if it is symmetrical about y-axis means x bar is 0. So here centroid equal to, we have to find out x bar and y bar. So T section is symmetrical about y-axis, so that's why x bar is going to become 0. So 0 comma y bar, because centroid lies on this y-axis, so we have to find out the exact location of centroid on this y-axis. So if the centroid is lying on y-axis means x bar is 0. So we have to find out y bar. So here y bar equal to a1 y1 plus a2 y2 by a1 plus a2. So area 1 means, so area of first rectangle 80 into 10. So we are directly substituting 80 into 10 y1. So y1 means centroid of first rectangle or first element. So this is the first rectangle, it has depth, it is 80 mm. That means for this rectangle centroid lies at center. So here we are assuming this is the center. So it is y1. So centroid of first rectangle we are measuring with respect to x-axis. So y1 y2 means centroidal distances of those particular elements with respect to x-axis. So this is y1. So this total depth or length is 80. That means y1 equal to 40. So here y1 is 40 plus area 2. So second element, so it is 10 into 50. Area 2 is 10 into 50, and y2 means centroid of this second centroid lies at center for the second element. So we have to measure y2 means distance measured, distance of centroid of second rectangle with respect to x-axis. So here this is y2, centroid of second element, which is measured from x-axis. So y2 is here. So from here to here it is 80. So from here to this central distance is 5. So total is 85. So this total distance is 80 plus 5, because this total thickness of second element is 10. So central as its center means this distance is 5. 5 plus 80, total 85. So all dimensions are in mm. So by default all dimensions are in mm, that's why we are not mentioning here anything. So y2 is here 85 divided by a1 plus a2. So 80 into 10, 800 plus 10 into 50, 500. So if you calculate this, finally you will get centroid location y bar equal to 57.3 mm. So y bar equal to 57.3 from x-axis. So from here, from this x-axis, 57.3. So here it is 40 means 57.3 means it may lie here. So centroid of with the star mark we are presenting, centroid of this total T section or compound section is here. Y bar equal to 57.3 mm. 57.3 mm. So now we are going to find out moment of inertia of this T section about centroidal axis. So centroidal axis means the axis which are passing through centroid. So here we are assuming x axis which is passing through the centroid and y axis which is passing through centroid. So here we have to find out first moment of inertia of given section, about x. Here Ix moment of inertia of given section about Xx equal to, so here we are drawing up this is the centroidal axis. Here we are assuming it is xx. So about this centroidal axis we have to find out moment of inertia. Ixx will be equal to, so here we have again two elements, rectangle 1 and rectangle 2. For this rectangle 1 again we are having one centroid, so with respect to this centroid we have to find moment of inertia about a and with respect to, by considering this centroid also we have to find moment of inertia. So here Ixx will be equal to Ixx1 plus Ixx2. So by applying parallel axis theorem, so using parallel axis theorem, so Ixx1 means moment of inertia about centroidal axis of that first element plus G1 into distance between the two axes, that is here. So instead of h1 here we are assuming that is hy1 square. So this is Ixx1. Ixx2 means moment of inertia about a centroidal axis of second element plus area 2 into hy2 square. So instead of h1 h2 here we are considering hy1 hy2. So whenever you are going to find out moment of inertia about xx, because we have to find out moment of inertia about yy also, so at that time there we will take these distances as hx1 and hx2. So first one Ixx1 using parallel axis from Ixx1 means here Ig1 plus A1 into hy1 square. So Ig1 means moment of inertia of first element about its centroidal axis. So here this is the first element. So moment of inertia of this first element about its centroidal axis. So about its centroid. So we know the formula B dq by 12. So here it is B1 d1 cube by 12 plus area 1 into hy1 square. Here hy1 means distance between centroidal of distance between centroid of total T section to centroid of first element. So distance between centroid of T section. So centroid of T section means here this is the centroid of T section and centroid of first element is here. The difference between these two means this is the distance between those two centroids, or the distance between those two centroidal axes here hy1. So along y-axis here we are measuring the distance. That's why here we are mentioning with the letter hy1. So here B1 means here width is 10, depth is 80 for the first rectangle. So 10 into 80 cube by 12 plus area is 10 into 80. So here HY1. So here HY1 is the distance between the centroid of total compound section, that means centroid of T sections to this centroid of first element. So here this is the distance. So either it is minus or plus, you have to neglect those negative values. Here we have to measure the distance between those two. So from here to here it is 57.3 and from here to here it is 40. So 57.3 minus 40, that means 17.3. So here it is HY1 is 17.3 mm. So along this y-axis we are measuring so vertically we are measuring the difference between these two. That's why here we are mentioning with HY1. So whenever you measure horizontally, at that time we are going to represent with HX1. So the difference between these two centroids, the difference between these two central axes, here we are presenting with HY1. So if it is 17.3 mm. Into 17.3 whole square. So if you calculate, then you may get some 6098.67. So it is a moment of inertia. So its units are mm to the power of 4. So moment of inertia. So whenever you consider a first element, so now Ix2 equal to Ig2 moment of inertia about centroidal axis of second element plus area 2 into Hy2 square. So B2 D2 cube by 12 plus area 2 into Hy2 square. So here width is 50, depth is 10. So 50 into depth is 10, 10 cube by 12 plus 50 into 10 Hy2. So Hy2 means distance between centroid of that T section to centroid of second element. So here centroid of T section is here and centroid of second element is here. So the difference between these two points is here Hy2. So centroid of the total compound section to centroid of second element. So if you measure the distance between these two, so it is here. So along vertical direction we are measuring, that's why Hy for second element y2. Hy2 equal, we know from here to here it is 85. From this 85 you have to minus this value. So from this total 85, if you minus this value, if you deduct this value, you will get the distance between these two axes. So from here to here means it is y bar 57.3. So total is 85. From 85, if you remove this 57.3, so 85 minus 57.3, so you may get some 27.7. So this is hy2, 27.7. hy2 is 27.7 whole square. If you calculate this, you may get some 38711.67 mm to the power of 4. So moment of inertia about centroidal axis, x-axis is ixx1 plus ixx2 will be equal to, so if you add these two values, so you may get some 1053910.3 mm to the power of 4. So moment of inertia of that T section about centroidal x-axis is here 1053910.3 mm to the power of 4. So about centroidal x-axis we calculated this moment of inertia. Now we have to find out moment of inertia of given section about y axis. So here about the y axis means centroid is always lies on y axis. So Iyy, moment of inertia about centroidal y axis will be equal to Iyy1 when you consider first element, and when you consider second element it is y2. So Iyy1 means moment of inertia about centroidal axis of first element plus a1 into hx1 square, hx1 square. So this is Iyy1. So here hx1 means the distance between centroid of T section to centroid of first element along x-axis. So here hx1 means, so centroid lies on y-axis, centroid of first element also lies on y-axis. So we will get only hy1 only. So we are not going to get hx1 because along the x-axis we are not going to the distance between those 2 points is 0 because those two centroid lies on y-axis only. So measuring distance along horizontal direction along x-axis is 0. So centroid of first element lies on y-axis, centroid of this total section also lies on y-axis only. So these 2 points are on y-axis only. That means you are going to get only hy1 values. So hx1 values or horizontal difference between those two central axes is 0. So here hx1 is 0. Similarly hx2 is also 0. So Iyy1 will be equal to Ig1. Similarly Iyy2 will be equal to Ig2 because hx2 is 0. So Ig1 means moment of inertia of first element about its centroidal axis. So Iyy2 equal to Ig2. So moment of inertia of second elements about its centroidal axis. So here Iyy1 equal to Ig1. So along y-axis, that's why here the formula will become like this: d1b1 by 12. So along this y-axis, so this is the dimension. Along y-axis, the dimension is 80. So this one comes first, so that is depth 80. So remaining dimension is 10. For this 10 you are going to get cube d1b1 by 12. Similarly Iyy2 equal to Ig2 because hx2 is 0, so the remaining term all becomes 0. So Ig2 equal to d2 b2 by 12. So there d2 means, so 10 is d2 and b2 is 50. So 10 into 50 cube by 12. So total moment of inertia about y-axis will be equal to Iyy1 plus Iyy2 equal to, so if you add these values, so you may get some value, that is W110833.33 mm to the power of 4. So moment of inertia about y-axis. So when that particular composite section is symmetrical about y-axis, then hx1 hx2 will become 0. So if that composite section is symmetrical about x-axis, then hy1 hy2 will become 0. So here if that section is symmetrical about y-axis, then we are going to find centroid y bar, since x bar will become 0, so y bar is sufficient, and the distance between those central axis will become hx1 will become 0 and hx2 will become 0 and so on. If 3 elements are there, then hx3 will become 0. If that given section is symmetrical about x-axis like channel section, then you are going to find centroid formula x bar a1 x1 plus a2 x2 by a1 plus a2, there y bar will become 0. So if it is symmetrical about y-axis, x bar will become 0, you are going to find centroid y bar. If the section is symmetrical about x-axis, y bar will become 0, you are going to find x bar. and hy1, the distance between those two centroidal axes. So composite section centroid and those centroid of those particular elements, the distance between those two centroidal axis will become 0, that is hy1 equals 0 and hy2 will become 0. But you have to find hx1 and hx2. So whenever the section is symmetrical about x-axis. So these are the 2 points you have to remember for easy calculations.